That's right. Today I'm at the beach, which got me thinking about this classic question. Are there more grains of sand in all the beaches in the world, or more stars in the sky? Now, if you want to take a guess, or you think you have an idea of the answer, go ahead and let us know in the comments before we get started. Now, the first thing we have to talk about is what kind of sand we're working with. Now, it may just seem like sand is sand, right? It seems like it'll be the same all over the world. But actually, depending on your location, whether it's beach sand, sand under the ocean, or sand in a desert, that it actually behaves very differently. It had different properties. So right now, I am in Gulf Shores, Alabama. It's at the very tip of Alabama in the Gulf of Mexico. And based on some research done, thanks to the Bureau of Ocean Energy Management, I have learned that the sand here is about 0.5 millimeters in diameter on average. So we're going to be taking that as our working value. So, on to some of the math of the video. We're going to have to calculate the volume of these sand grains, which is not so easy to do considering how jagged and angular they are, particularly on this part of beach. Now, we're going to have to take an approximation, otherwise this is a really futile task trying to figure this out. So we're going to approximate these as spherical grains, even though that's not perfect. It'll be close enough for our purposes, dealing with such large volumes. If the answer is off by a factor of 10, it won't actually be an enormous difference based on the scales that we're working with. So we're going to have the diameter that we've already found with the volume of a sphere. Between those, we can find that the average volume for these particles is about 0.065 cubic millimeters. Now, that's not the only thing we have to take into account. We also need to consider that not all of the sand is actually particles. If you take a volume of sand, a significant amount of it is actually air in between the gaps in between these particles, since they don't lock together perfectly. Doing some more research, I found that the void ratio of this sand is about 1/2, which means that for every cubic millimeter of sand that we calculate for, we're going to have to add 50% on top of that. Taking all that into consideration, I have found that in the average cubic centimeter of sand on this beach, there's about 10,000 individual particles. So we're going to take that as our working value. So here is our first stop. This individual sand grain, which barely shows up on camera, will represent our sun. Almost everything you've ever known represented right here in this tiny little speck. Here we have our next milestone, which I've done my best to gather in one place so it's a bit more visible. These are all the stars within 100 light years of the sun. It comes to about 500. It's just starting to become a visible pile. So now we've bulked up in volume significantly. We've gone from stars in 100 light years of the sun to stars within 1,000 light years. You get two large cups about this size, about 1.5 actually, and you've gone up significantly from our little speck right here to go up from 100 to 1,000 light years. Now that's because as you increase radius, the volume increases according to the cube. So you get dramatically more grains of sand and thereby stars. Now the next two volumes of sand I'd probably get in trouble if I tried to bring inside. So I'll include the picture of the first one here. Now this is a square that I've marked out in the sand that is about 5 feet on each of its sides. And you can sort of imagine it going down an extra 5 feet, so it's a cube. That is the volume of sand that you would need to represent the Large Magellanic Cloud, which is a sort of dwarf galaxy that orbits the Milky Way that you can see in the southern hemisphere. Now, if you want to represent the entire Milky Way galaxy, you can do so like this. Done the same thing, except now the side length is more like 10 feet. So you can imagine it's sort of the size of an average parking spot. And you can have that number of sand grains representing the entirety of our galaxy. Which, don't get me wrong, it's quite a bit of sand, but it's surprisingly small for as many stars as there are in our galaxy, roughly 250 billion stars, and here 250 billion approximately grains of sand. One of the interesting factors that we haven't taken into account is the space in between these stars. Now, we've been representing them in a fairly compact way, even with a few gaps. They've all sort of been in one place. Now, what happens if we start to accurately represent the distances on these scales? The Sun being half a millimeter, the distance to Earth is about 2 inches, about 5 centimeters. The distance to Pluto, everyone's favorite downgraded dwarf planet, is about the distance from me to you, about 2 meters, 7 feet. The mind-blowing thing is when you start talking about other stars. Now, the closest star, Proxima Centauri, is about 4.3 light years away. At this scale, 4.3 light years, 17 kilometers, about 10 miles in any one direction. At eye level, I'm about 6 feet tall, I can see about 2 miles into the ocean, give or take. I can't even see the nearest star. In order to do that, I'm going to have to go a little bit higher. Now that I'm up here at my room, it's on the 5th floor, it's about 50 feet above sea level, only now can we start to think about seeing 10 miles into the ocean. From here, at the very edge of the horizon, we can just start to see the nearest star on this scale. And that's just the nearest star. If we start to think about the entire galaxy, kilometers aren't even a good unit anymore to describe them, even on this scale where a single star is less than a millimeter wide. Now, instead of going out, we have to consider up for the entire Milky Way galaxy. At this scale, if one edge of the Milky Way galaxy started here, the other end of it would be halfway to the moon. That's unbelievable. So really, what is the correct answer to this question is whether there's more grains of sand or more stars. In reality, we're never going to know. Estimates right now say that there are approximately 100 sextillion stars, that there are hundreds of billions of galaxies, each with hundreds of billions of stars. And at this point, we're dealing with numbers that are too big for me to even quantify to you, even with these analogies. However, based on these estimates and how many grains of sand there are on all the beaches, it turns out that it's about a tie. So, there you have it. If you take the volume of all the sands in all the world, and you can think about each individual one as a star, that represents all the stars in the universe. Of course, there's a lot of confounding variables that we couldn't even imagine that could be throwing both of these numbers off. Not to mention the fact that this is only considering the sand on exposed beaches, not including underneath the ocean or inland any amount. Even then, the fact that both of these numbers could be off by several orders of magnitude, the fact that they are roughly equivalent and such gargantuan values, I find very interesting to think about. That every time that you step over a sandy beach or on the dunes, that you could consider each individual particle, as small as it is, to be an entire star, its own solar system, which can average 1 or 2 planets orbiting each of them, which is truly a testament, as Carl Sagan would say, to the billions and billions out there. Thanks you all for watching.